Hi, my name is Nicholas Garneau. My partner for this project is Danielle LaPointe, and we are
Hi.
examining the reality of the high heel shoe. An interesting fact about high heel shoes is that at the point of impact with of the heel, there's actually more pressure than that of an elephant standing on the ground. As you can see in the upper right hand corner, at the point of contact with the ground, the heel has 3 megapascals of pressure, whereas an elephant it's only 125 kilopascals.
Some say that high heels may lead to physical injury. Are these vicious fashion haters, or is it the ugly truth? That, my friends, is a heel spur.
What we were looking for in our analysis of the high heel shoes was the stress distribution in the high heel with respect to angle. How does the angle affect the stresses? At higher angles, is there more stress throughout the heel than at lower angles, and what is that stress? And we're also looking at how the angle affects the platform height and that's impact on stress concentrations.
For our design assumptions, we chose to only model the structural skeleton of the shoe because we believed that all stresses of interest were concentrated to the platform, shank, and heel, and all other stresses were assumed to be zero. We chose steel to be our material to model. This is the anatomy of a stiletto. The red arrows indicate the platform, shank, and heel respectively.
The loading scenario used was based on that of the statistics of an average American woman. A height being of approximately 5 feet 4 inches and 162 pounds with a shoe width of 3.63 inches and length of 9.81 inches. As you can see below are the material properties for skin, bone, and steel.
This is our first design. We chose a 2.845-inch platform heel, or platform, with a 6-inch stiletto heel, which resulted in an angle of 30 degrees with respect to the ground. The upper left photo shows our original NX design, and the other photos show the ANSYS analysis. In the upper right-hand corner, you can see the stress concentrations in the heel of the shoe, and then in the bottom left corner, the maximum stress occurred at the outer edges of the ball of the foot, resulting in about 400 psi.
The 45-degree angle resulted in a platform height of 1.54 inches. As you can see in the upper right-hand corner, the heel is beginning to deform and the largest stresses are occurring there. However, if you also look where the slant of the heel levels out, where your toes and the ball of your foot would sit, there's a significant amount of stress, approximately 137 psi. This won't result in serious injury, however, wearing these heels all day could result in a lot of pain for your feet.
The 0.535-inch platform heel is not only visually frightening, but physically terrifying. You can see that the heel is actually beginning to deform significantly. The stresses all over have increased, and the maximum stress is over 800 psi.
Our findings: with a heel cross-section area of 1/8 inches squared, we saw that at 30 degrees, the stress was 403.25 psi. At 45, it was slightly greater, though not very much, at 410.59 psi. However, at 60 degrees, we saw a significant jump all the way to 822.74 psi. What this means is, though we don't have enough data points to confirm, it is likely an exponential increase.
Our recommendations. So ladies and fanciful gentlemen, we recommend low angles, thick platforms, and minimum use. Unfortunately, the vicious fashion haters are right, and with prolonged use, your feet may become deformed. However, for the purpose of this analysis, static loading will keep your feet intact.